Greetings, everyone. And what we are doing is we are introducing a comprehensive microeconomics for business course. Uh, the hopes for this video series is to teach a full comprehensive course. It is a college level course, microeconomics for business. So there's probably going to be more than one video for our introduction. The purpose of this video is to kind of give a thorough introduction. Um, but to start, we can we are going to cover microeconomics in exactly 13 chapters. So exactly what these headings mean, we find out as we go along through the series. But we are going to present a full comprehensive, complete with problem sets and examples, a full comprehensive microeconomics for business in 13 chapters. So what we're in right now, let's see if we can just say hi. Yeah, perhaps we can zoom in. Microeconomics for business. Uh, the simplest, maybe not the most proficient, but the simplest way to do these videos is, of course, just to print them out on Zoom, which is what we're doing here. So, like we said, we're going to teach a comprehensive microeconomics for business course. It will be done in 13 chapters. This video series can be considered a full textbook. So it's not a textbook, it is a video series, but a video series is exactly the same as a textbook. Yes. So it's meant to kind of go from front to back, just like a textbook. And it's kind of like, any recording of a book that we might have had growing up. You can read a book, or you can just have a recording where somebody says it to you. A video series is kind of obviously we can pause, move back and forth, just kind of dwell on the examples. But anyways, I tend to repeat myself. So this is the video that we're in. Like we said, the introduction will take more than one video, but we're in chapter 1 right now, which is simply the intro. We're going to discuss a little bit chapter 2 to 13, exactly what we're going to be studying in this course. Yeah. But to start our introduction, we simply want to quickly outline the table of contents. What exactly are we going to learn in this book? Yeah. Okay, so chapter 2 will be Yep. Chapter 2 will be a very brief math review. We can kind of discuss that right now. Yes. So we will get into that a little bit more thoroughly, but one obvious question is what math do we need for this class? Now, what I like to say, it's very general and a little bit silly, but what I like to say is we do need a very thorough understanding of graphs. Anybody who comes from a strong mathematics background, that kind of goes without saying. But any math we do in microecon is very light algebra. It's very light, a few proofs, not many, some calculus and all of that, very light algebra. But we're very quickly going to get into economic models here. So it's more about understanding graphs. We don't state a class like Calculus 1, but we do have to have a very strong graphical understanding, if that makes sense, and kind of understand all the nuances within a graph. That goes without saying. Okay, so I just want to make a note on the side. We're going to make a side note here. Not all of this is required. We're going to get back to this in chapter 2, but we can talk about it now. Yeah. So if somebody said straight up, what do we need for this class? The answer is Calculus 1. It doesn't matter if we had Calculus AB in high school. Sometimes they call it, Calc AB. That's more of a high school thing, or honors calc. What we're mainly talking about is Calculus 1 uh, from a community college or university. If we had calculus in high school, it's more or less the same thing, that's fine. So we have kind of a few ambiguities. We're not really saying this is just my opinion. So it's not quite thorough here, but we have a few things. We have calculus 1. You do not need calculus 3. We do not need calc 3, which is multivariable. Uh, let's not mind the spelling there. Yeah, so calculus 3, which is going to be a multivariable calculus. This is something that we really don't need. Um, Now from calculus 1, we of course have basic integrals, derivatives. So we have to know all of our algebra. Yeah, there's not going to be any trigonometry really, but we have to know all algebra from, all the way up through college algebra, things like that. And we have to know our calculus 1, but we have max and min problems. Yes, so we have max and min problems. We have this idea of optimization. Yes, so we have this idea of optimization, which is really just the same as min and max problems. So there's a couple of things that are confusing. I know I said that we don't need calc 3, multivariable calculus. Why would I say that? Because we kind of do need calculus 3. There's two major points from calculus 3. They're not made clear in calculus 1, so we don't necessarily had to have had calculus 3, and it's not a prerequisite to this course. Yes, but one, it's very hard to describe the optimization. We get into this whole other conversation that we're going to get in chapter 2, so we might as well wait. But number 1, we have to know how to do partial derivatives. So we do have to know how to do that, which is a multivariable calculus 3 thing. Yes. And we have to know three-dimensional optimization is what I was talking about a moment ago. Three-dimensional optimization is not like one thing. I wouldn't be able to say it all at once, but there's a good handful of ideas all wrapped into three-dimensional optimization. So we have to know that. But let me just kind of write a few things here. Yeah, so we do have to have strong algebra all the way up to college algebra. We have to have been through calculus 1. That way we know all of our basic integral and derivatives. Yeah. Now we do have to know the two-dimensional max and min. Yeah, two-dimensional max and min. That's basically take the derivative, set it equal to 0 to find the max and min where the derivative is the slope. Yeah, so we get all into this later. The more I talk, it doesn't really help us now. Now, optimization, that word optimization, that obviously has to do with max and min have to do with that, but that makes it a lot harder. We don't have to have, finite. I'm just talking about some ideas here. We don't have to have finite or discrete. We also don't have to do that. But why would I mention that? Because we have these word problems. We saw them somewhere. It doesn't matter if it was pre-calculus or where, and some people didn't see them. Where, of course, y is greater than or equal to 0 because we're talking about money or time or something where we can't have negative numbers. Yeah, we have, I know it seems weird putting that over there, but remember y greater than or equal to 0 is above the x-axis. Yeah, so we have some of these confusing, it's more the sophistication of math. We have x greater than or equal to 0, just means that we're shading that way, yes. Yeah, and then we have one of these dilios here, that's a straight line. And then we have one of these guys right here, that's a straight line. And then we have this shaded region, yes. This is optimization that's of the most elementary form is what we're talking about. And then we have these corner points, yeah. Then we have these corner points and we plug them into this z function. This is ambiguous, we never learned this, but we have like a three-dimensional graph overhanging this thing, 2x minus 3y or something. We have this z function, we plug the stuff in there and we find the highest one. So this is optimization, and we do have to have this for econ. It's a very easy thing. But honestly, in a college level economics course, we go beyond that. So that's just kind of an introduction that we don't always use. Okay, so once again, uh, I do sometimes repeat myself. It's just how we kind of go through this. We mentioned calculus 3. We'll get into this later, but in calculus 3, they teach kind of the three-dimensional max and min. Yeah, the three-dimensional max and min. So we can learn this stuff quick. We have to learn it later. The three-dimensional optimization. Usually the maximum is not going to be that. It's going to be, what do we call it, a constraint. If I really, really just trace this line here, if I really, really trace that line, we have a constraint, and usually the maximum is somewhere on that right there. So we do have calculus 3, multivariable optimization, max and min will come up quite a bit in this course, so we need that. And lastly, we have to know how to take partial derivatives. Okay, so we do have to know how to do partial derivatives. We're going to review that in chapter 2. So it looks like kind of a mess, but we can kind of, we at least have the ideas there. But all we're kind of doing here is we're presenting the chapters that we're going to go through in this book. I think it's okay to just erase this here. Okay, so let's just kind of jump right in and quickly outline the table of contents like I was saying we're going to do before I